Example 9, a rock attached to a string is whirled horizontally in a circular counterclockwise path about the origin. So that sentence describes the motion of this, this rock on a sling. Okay? The sling apparently is about 5, whatever unit we're dealing with. Let's say, doesn't give us units. Let's just say 5 feet long. So we got a 5 foot long string, person's whirling the string around their head, the person staying at the origin, and they have the ability to make the rock shoot out of the sling towards this wall because apparently they want to hit this wall. Wall said something mean to him and he's, I'll get you, and he takes the rock at him and puts a little chip in the wall. Anyway, it tells us the wall is located at y equals x plus 12. Every time you get a problem like this, you're going to get one in the independent practice, one in the homework, maybe 2 in the homework, I can't remember. But the wall is going to have some linear equation representing it. If they tell you the linear equation, that's a bonus. If they don't, you can figure it out. Here's the wall. It goes through. It's y is it a 2 scale? X is it a 2 scale? All right. So 2, 4, 6, 8, 10, 12 is the y-intercept. And we're going up 1, right 1 to get from point to point. Actually, up 2, right 2 to get from point to point. Still, 1 over 1 represents a 1 slope, 1x plus 12. So we'd be able to determine the equation of the wall if they didn't give it to us. If the wall is horizontal, y equals number. Vertical, x equals number. So those possibilities exist also. But every time we do this, we're going to have the person flinging a rock at a wall. All right, the wall is going to have some linear equation represented. All right. The string breaks when the rock is at at point 4, 3. So right here is where the string breaks. And the physics of the problem, if you're whirling a rock horizontally around your head like this with a sling, if the string breaks, the rock's going to go perpendicular to the radius at that point. So I know that the string and the path of the rock are perpendicular to one another, just based on regular physics. So you can always make that assumption on this problem. Okay. Our task is to establish the point at which the rock hits the wall. So we're looking for ordered pair x comma y where the rock hits the wall. So what I need to do is I need to find the equation of this line here. If I find the equation of that line, wherever that line hits the wall, is the answer. This is a linear equation. That would be a linear equation. That gets me 2 linear equations I solve by substitution or elimination, like we did back in Algebra 1 and or Algebra 2. So, let's look at how we determine the slope of this blue line here. All right? If I were to imagine this as a line, imagine that line there, right? It has some slope. How do you make a perpendicular slope?
Is it just opposite?
Opposite
no.
and?
Opposite and
reciprocal. Yeah, opposite reciprocal. So looking at this red line, the red line represents the string, right? The string obviously is a segment, not a line, but if we can superimpose a line over where the string would be, right? Looking at that line, obviously the point of the origin is involved on that line. Also the point they gave me 4, 3 is on that line. I can find other points if I wanted to, but the origin for sure, because that's where we're swirling this string around, so it's connected to 0, 0. It broke at 4, 3, so 4, 3 is also on that line. So the slope of the red line, I'm going to M sub r for red, is going to be y minus y over x minus x. Keep in mind the origin's coordinates of 0, 0. So y minus y on top, x minus x on the bottom, the basic slope formula we always use. So the slope of the red line is 3/4, which means the slope of the blue line, the one I care about, is going to be negative 4/3. We also know to find the equation of a line, we need to do y equals mx plus b. Looking at the graph, 2, 4, 6, looks like 8. Don't make assumptions though. Okay, figures aren't always trying to scale in this problem. So algebraically, we can determine the y-intercept by doing our normal y equals mx plus b. We need a point that lies on the blue line, and the point 4, 3 fits that description, right? 4, 3 lies on the line. Okay, so when you do one of these problems involving a person using one of these circular slings to sling a rock, that's how you figure it out. So the point here with this origin gets you the slope of the string. Opposite reciprocal gets you the slope of the same point. Used with that slope gets you the equation line you're looking for. So if I go to y equals mx plus b, using this y, which is 3, this m, which is negative 4/3, times this x, which is 4, plus b. That gets me 3 equals negative 16 thirds plus b. Trying to solve for b, I need to move the 16 thirds over. To add or subtract fractions, I need a common denominator. So I would probably change that into 9 thirds, just to get the common denominator there. I move the 16 thirds to the other side, I end up with b equals 9 thirds plus 16 thirds, which would be 25 thirds. Just a little bit bigger than 8. 25 is 8 1/3. So again, it looks like 8, but it's actually 8 1/3. So again, don't go by looks, go by the algebra to get that. So the equation of the rock's path, the blue line, is going to be y equals negative 4 thirds x plus 25 thirds. Now, most of us like elimination better than substitution, right?
Yeah,
It's usually more efficient. Yeah, whatever works. In this case, substitution works fine, but we got all these fractions to deal with anyway. What I would probably do with this blue equation is I'd take everything times 3 to get rid of the fractions. So 3y is equal to negative 4x plus 25, which becomes 4x plus 3y equals 25. 4x to the left becomes positive, 3y stays on the left, stays positive, 25 stays on the right, stays positive. The other equation, y equals x plus 12, if I slide the x over to the left-hand side, I get negative x plus y equals 12. Now I'm looking at this system of equations in order to figure out the point of intersection of the rock with the wall. That's the rock's path, that's the wall's equation. If I find where those two things intersect, that's going to be the coordinates of the point where the rock hits the wall. So if I just go to this new page here and just do that, I would multiply the bottom equation by 4. So I've got 4x plus 3y equals 25. It stays the same. Take this bottom equation times 4. Gets me negative 4x plus 4y equals 48. Negative and positive 4x cancel. 3y and 4y make 7y. 25 and 48 make 73. 73 sevenths. 10 and 3 sevenths, if you wanted to make a mixed number out of it, I wouldn't. I'd keep it 73 sevenths personally. If I want to figure out what x equals, I'd probably go back here. Y, which is 73 sevenths, is equal to x plus 12. Multiply the entire thing times 7 to get rid of the fraction. 73 equals 7x plus 84. That fraction goes away. Both of these numbers become 7 times bigger. Move the 84 over. Subtract because the signs are different. Negative because 84 is bigger. Divide both sides by 7. Negative 11 sevenths is x. So the point of intersection, the point at which the rock hits the wall, is going to be negative 11 sevenths, comma 73 sevenths. Suppose, just for the sake of some of the problems, because this problem's harder than some of the problems, but then it's not exactly the same. So people are like, I don't know how to do it because it's not exactly the same. All right, if you're that person, you don't know how to do it because it's not exactly the same. Suppose the wall had this equation. 2, 4, 6, 8, 10, 12. Y equals 12. We want to know where the rock hits the wall. Y equals 12, right? The equation of the rock is this equation right here, right? And y equals 12. Change that to a 12. All right? So the answer is something comma 12 because that's the y coordinate of the wall. It's got to hit the wall where the wall is. All right? So y equals 12 is where the wall is. So basically you just have to find the x coordinate. So we get 36 equals negative 4x plus 25. Move the 25 over. You get 11 equals negative 4x, which gives me negative 11 fourths, comma 12. All right, so if the wall happens to be horizontal or vertical, x equals, then you already know x, you just have to find y. They're easier in that scenario, but in past years I've had students that got freaked out because it wasn't exactly the same as the example problem. As always, use your brain a little bit before you come freaking out to me about how problems aren't exactly the same. But that's how you handle it in that situation. Again, I know that the horizontal wall happens at least once. I don't remember a vertical wall happening, but if it does, that's how you handle it. Otherwise, if the wall is slanted, it's just going to be xy equation, xy equation. You just have to determine the coordinates by elimination or substitution. Most of the time the answers are fractions. Leave them as fractions, so just deal with it. You guys are in Geo Trig, you're smart enough to handle fractions.